Policies provide a declarative way to grant or deny access to paths and operations in Vault. In this talk, I will take a deep dive into Vault ACL policies. Hello and welcome to this session at HashiTalk ANZ 2022. I am Pratik Khasnabis, a Senior Customer Success Architect at HashiCorp based in Brisbane, Australia. In today's talk, I will explain the concept of policies and how it is tied to authentication and tokens in Vault. I will go through the rules to build a policy in Vault. I will show some patterns to use policies together with identities. Finally, I will show some advanced features like fine-grained policies. Let's take a quick overview of Vault. We define Vault as an identity-based secret and encryption management system. The keyword here is identity. An identity of a client is something that uniquely identifies it. The client can be a human user or a machine. It has to prove Vault its identity through the act of authentication. This can take many different forms. For a machine or application, it is commonly a native mechanism of the platform in which it is hosted. For example, AWS IAM role or Kubernetes authentication method. For a human user, it is commonly through schemes like OIDC or ldap. Vault also provides a simple user pass authentication method that I will use for my talk. Vault policies and client tokens, let's say how it fits together. Most Vault operations require a valid token. For example, to read secrets from Vault, the read request must be accompanied by a valid token. The token has one or more policies attached which dictates what operations are allowed. To get a token, each Vault client must authenticate with Vault. Upon successful authentication, Vault will issue a token. The client can use the token to make requests through the life of the token. The diagram here shows that the Vault admin is responsible for creating policies based on the policy requirements for each client, enables and configures the auth methods. The client app1 will authenticate with Vault via Kubernetes auth method. When the app1 identity is validated, Vault will generate a client token with policies attached and return it to app1. Let's take a quick look at the language of policies. Policies are written in HashiCorp configuration language. Everything is path-based and corresponds to Vault API endpoints. Policies grant or deny access to certain paths and operations. An empty policy grants no permission. Remember that Vault is denied by default system. No policy means no authorization. Let's take a quick look at an example policy. In this case, the path is secret/data/user/Ravi, where secret/data is the default engine path for KV version 2 secret engine. User/Ravi is the path of the actual secret. The capabilities this particular policy provides is the read capability. The capabilities map to HTTP verbs on the API endpoint for Vault. Vault's architecture is similar to a file system. Every action in Vault has a corresponding path and capability. Each path is expressed with the path keyword followed by the absolute path expressed as a string and a stanza that defines the capabilities and other configuration. Vault Enterprise can also employ namespaces to further define a path. What are the various capabilities that are available? These are create, read, update, patch, delete, list. These matches with the HTTP verbs. For example, create capability match with the post and the put HTTP verb. There are two special capabilities, sudo and deny. Let's have a look at the Vault policy HCL syntax. Few things there are glob, which is the star character, and the wildcard, which is the plus character. The glob is any character after the string only at the end of the path. The wildcard or plus character is any character within a path segment. Also, the path can have templates, which we will see. The capabilities we have already gone through. For fine-grained policies, we also have parameter constraints where we can have allowed parameters, required parameters, and denied parameters. In addition, there is also the capability of response wrapping, providing the time to live or TTL for the min wrapping and max wrapping. In this talk, I have some policy requirements. All users should have access to their own secrets at path user / the name of the user and any subpath after that. Users can authenticate using user pass and ldap auth method and should have same policies regardless of their auth method. All users should have access to their team's secret at the path team / name of the team and then subpath after that. The theme for the user is based on the LDAP group the user is in. We also want to restrict encryption operation options and parameters for user. Without much further ado, I will now go into Visual Studio Code where I will show some examples. This is the Vault UI and this is my Visual Studio Code. I have logged in with the root token on the left terminal pane, and I will use the right terminal pane for a normal user. I have already enabled the KV version 2 secret engine user plus auth method and created 3 users, Ravi, Mary and Alice. I have also listed these users as you can see in the output, and I have run the command vault policy list, which shows there are just 2 policies there, default and root. These are the 2 built-in policies in Vault. Let's now log in as Ravi and see if Ravi has got access to the user's secret path. The token that is returned after authentication shows there is only the default policy attached to the token, which means it should not have access to the user path. Let's try that one anyway. As you can see, it returned a 403 code that there is no policy that grant access to this path. That means we now need to grant the policy that is required. On my admin terminal, I run the command vault kv get -output -policy and the path. This is something that is available since Vault version 1.11. This parameter shows the policy that is required to access that particular path. In this case, the capabilities are read and the path is there. I can give it to this particular path, but let me give the policy to using a glob character so that all the subpath from Ravi, user/Ravi, will have access for Ravi, and the capabilities will be all the capabilities. So I've created a new policy. Quickly look at that one. So it's a Ravi policy, and the Ravi policy is all access to any subpath after user/Ravi with the capabilities for the whole CRUD operations. Let's assign this policy to Ravi in the user pass auth method. So Ravi policy has now been assigned to Ravi. Now I want to log in again. This time when I log in, I see that the Ravi policy is attached to the token. We can look at the capabilities of the token for a particular path using vault token capabilities command. Let's run the command. It shows that this token has create, delete, list, patch, read and update capability on this path. Let's try to get the secret or create a secret. Secret has been created. I'm going to read this one. This is the MySQL DB secret, and I can read that one. Let's create another secret for AWS credentials. This also works. Now, what happens if there are more users than Ravi? There may be hundreds of users in an organization. We cannot create a policy per user. We need to have some other mechanism of doing that one. This is where the concept of templated policies, entities and groups comes in. Let me go to the Vault UI. In the Vault UI, let me go to the Access tab and Entities. You see there is a thing called an entity. When Ravi authenticated using the user pass auth method, that authenticated identity was automatically created as an entity in Vault. This is this entity, and this entity has an alias for the particular authentication method that was used. If I click this one, it shows that this entity has an alias called Ravi using the user pass auth method. It is possible to create policies with templates from this identity. Let me quickly get the entity ID of Ravi. This is Ravi's entity ID. I want the entity alias ID. Actually, this is the alias ID. And the entity name. I'm trying to read the entity alias ID, and I can see that this is Ravi using the user pass auth method. Similarly, let me read the details of the entity. And this entity has got this canonical ID, and it has got one alias on the user pass auth method. These are the auth methods, and the accessor for the user pass auth method is this one. This can be used in a templated path inside the policy. Let me create this policy and I'll explain this one. So I created a policy called user policy. This is using the variable which is a template from the identity management system of Vault. It will use the name that is coming from the user pass auth method, and I'm providing the mount accessor of the user pass auth method in this template. The identity management system will inject the actual name of the authenticated account using the user pass auth method in the policy. Let me delete the Ravi policy just to be certain. So now we have got this user policy. I will assign this policy to our users Ravi and Mary. Let me now log in as Mary. I have logged in as Mary, and Mary, as user Mary, I will try to create a MySQL database secret. That works. Why it works? Because the user policy gives access to that path, because the name has been replaced inside the template. We can see that the token has the user policy attached. Let me try to quickly read this secret. Yeah, we can read this secret. Now I'll try to log in as Ravi and just repeat the same thing. As you can see, Ravi has also got the same user policy attached, but Ravi has got access to the path which is for Ravi. What if I try to get a secret for Mary? So I'm going to do this one. We can see Ravi doesn't have access to Mary's secret. It only has access to his own secret. Let me go back to the next requirement. Users can also authenticate using ldap authentication method, and if they use that authentication method, then based on the group they are in, they should have access to their read-only access to the team secret at the path team/the team, and the name of the team is coming from the ldap group. Let's see how we can achieve this. I have already enabled the ldap authentication method and configured it. I am using JumpCloud, which is an online ldap provider. Let me create the engineering team policy. This policy provides access to the engineering team's secret at the path team/engineering/star. I created this policy, and now I attach this policy to the ldap engineering group using this command: vault write auth/ldap/groups, and then the name of the engineering group or the name of the group. Let me also create an example secret for the Tesla API. Can anyone understand the value of that key? I'll go to the UI to show this thing once again. On this side, let me log in as Ravi. If I go to the UI, we have seen that there was one entity for Ravi, and because I have logged in as Mary, there is another entity for Mary as well. This entity has the alias for Mary, so this is Mary's entity with 315, and this is Ravi's entity with 5702 and the alias that we have seen before. Let me just copy this entity ID, entity name, and the alias ID. I am going to delete this automatically created alias. And the entity as well. I'm also going to clear the user policy that we have attached to Ravi's user account in the user pass auth method. Okay. Let's go back to the UI. Now I see that Ravi's entity and its alias has been deleted. I will now manually create an explicit entity for Ravi to represent Ravi. Let me create that entity. I have created the entity for Ravi and also given the policy, user policy. Let me go to the UI and see this one. Okay, there is now an entity for Ravi, and this entity has the policy, user policy. Let me also create, and I need to get the ID for this entity created, that's this one. I will create two aliases for this entity. One alias will be for the user pass auth method using the accessor for that auth method. The other alias would be for the ldap auth method using the accessor for that auth method. So I created one alias and the other alias for the ldap auth method. We should now see these two aliases in the UI. Okay, we see that this entity now has two aliases, Ravi from the user pass auth method and Ravi from the ldap auth method. And the policy is now not attached to a particular auth method, it is attached at the entity level. Let's log in as Ravi using the user pass auth method. When I log in as user pass auth method, I see that the token policy is just a default policy, but it has still got the user policy, but it is now an identity policy because it is coming from the identity management system, not from the auth method or the method that generated the token itself. I should still be able to read the secret from db/mysql path because the user policy allows it. But if I try to read the secret for the team secret, that will not be allowed. This will only be allowed if Ravi has logged in using the ldap authentication method, because the ldap group that Ravi belongs to will have that policy. Let me log in now using the ldap auth method. I should still be able to read the user secret, and now I'll try to read the team secret. That's allowed because the engineering team policy is attached to the token, because this token was generated by the ldap auth method and we have given this policy to the ldap group. Let me go to the jump cloud UI to show this thing. So in the jump cloud, you can see in the user group, I have an engineering user group with Ravi and Mary both as users in that group. Because Ravi logged in, the group information came through ldap, it was matched in the authentication method and the appropriate policy was attached. There is another way and a more flexible way by which we can do this thing. This is by creating a group inside of Vault itself. Let me first clear the policy from the ldap group. I will now create a new group in Vault Identity Management System named Engineering, whose type is external, and it will still have the engineering team policy attached to it. This time, instead of hard coding the group name engineering or the team name engineering, I am going to use the template facility to get the name from the actual group. This is the group ID that was returned. And the policy path will use the name of that particular group in its template. This will be injected by the identity management system inside the policy. Let me create this policy. Okay, I have updated the engineering team policy. Now what we need to do is to create a group alias. A group alias is similar to the entity alias, except it is for a group and it will be for the engineering group and the alias will be for the ldap auth method. The group ID again I'll just copy. I have created this group. We can see this in the Vault UI. In the Vault, if I go to groups, I can see there is an engineering group. This engineering group has one alias through the ldap auth method, also named engineering, and it has a policy attached, engineering team policy. Let me now log in as Ravi again. And this time I am going to use the ldap auth method for logging in, and I'll try to read the engineering team secret. That works, and the user secret, that also works. If we see the token, we see that the engineering team policy is now attached as an identity policy. Previously it was a token policy. Identity policies are policies which are assigned to identities, and this gives additional permission to a token on top of the existing policies. If the token presented on the API request contains an identifier for the entity, and if that entity has a set of policies on it, then the token will be capable of performing actions allowed by the policies on the entity as well. This is a paradigm shift in terms of when policies of the token gets evaluated. Before identity, the policy names on the token were immutable, attached at issuing time. But with entity policies, along with the immutable set of policy names on the token, the evaluation of policies applicable to the token through its identity will happen at request time. This adds enormous flexibility to control the behavior of already issued tokens. What it means is that identity policies are always evaluated when the request is actually made. I'm going to show a good example of this one. Let's say that Ravi has logged in through ldap and he is using a token, and the token has a long time to live. In the meantime, some sort of compromise has happened on the ldap authentication system of the company, and there is a emergency requirement to deny all access to the team secrets. How can I achieve this one? Let's see this. Let me just go back and copy the group ID. I am creating a new policy called deny policy. The deny policy will deny any access to the team secret based on the name of the group in the template, and this is how this looks like. And a deny policy is the special capability which will deny access to the path. Let me create this policy first, and now I will attach this policy to the engineering group. Go back to this pane. Remember, I'm not logging in again. I've got the same token, and I'm going to access the engineering team's secret API key Tesla. Let's try this one. This policy was an identity policy. The identity policy has now changed because I've added a new policy called deny policy, which denies access to that path, even though the token hasn't changed. But because the policy evaluation for identity policies happened at the request time, it was denied. This is a very powerful capability. Let's quickly do a Vault token lookup to see what the token looks now. If we see this one, now we see that the identity policy is user policy and a deny policy. So the engineering team policy has been removed from this identity and a deny policy has been put in place. This was quite powerful because even though we didn't reissue the token and Ravi didn't log in again, yet we could attach the policy to its identity and deny access that was required. I wanted to show a few more capabilities of the policies for fine-grained control. Some of these things are allowed parameters. For example, when creating keys, we can allow certain parameters to have certain values. For example, the auto-rotate period must be 12 hours or 24 hours. I'm using the transit secret engine in this example. And the key type must be AES 256 or RSA 4096 because that's what the security policy says. If somebody who has that policy, in this example Alice, tried to create a key with RSA 2048 key type, it will not be allowed because the only key types that are allowed are RSA 4096 and AES 256. Similarly, we have given a transit user policy to our users, let's say Mary and Ravi. They can decrypt using the policy, but they have to have wrapping of the output, which means the output is not the raw plain text. It has to be wrapped in a token, and that token will have a TTL which is a minimum of 1 second and a maximum 120 seconds. This will reduce the chance of the secret getting misplaced, and if it gets misplaced, because the token will expire, nobody can actually retrieve the plain text. Similarly, for encryption, there is a denied parameter of key version, which means that you cannot provide an older key version or even the current key version for that matter, because the default is the current version. So it will only allow encrypting using the current version. These are some of the fine-grained capabilities of policies that we can use. I'm not going to show this one because I'm running out of time, but it is something that you can look at later. I'll produce this code in my GitHub later. Let's go back and see what we have learned today. We have learned about templating of the parameters from the identity management system of Vault. We have seen that Vault has an identity management system with entities and groups. In this example, the group name was engineering and there were two entities, Ravi and Mary. Each one of them can have aliases, and it is possible to attach token at various levels in the hierarchy. We can have token policies at the auth method itself, or we can have identity policy at the entity level or identity policy at the group level. So the key takeaways from my talk today is: use policies for access control, create entities and groups, use policy path templates, and assign policies to entities and groups for your access control. Once again, thanks for attending the session at HashiCorp ANZ 2022. Thank you and enjoy the rest of the day.